Mastering the for loop in C. The for loop is one of the core control structures in C. It allows you to repeatedly execute a block of code as long as a specified condition is true. Why the for loop is crucial in embedded programming? Did you know that nearly every embedded system uses loops? From blinking an LED to reading sensor data in a timed manner, loops are at the heart of these repetitive tasks. That's where the power of the for loop comes into play. Whether you need to read a sensor 10 times or toggle a GPIO pin with precise timing, the for loop gives you control, efficiency, and clarity. Detailed explanation of the general syntax of the for loop in C. The for loop in C is structured to run a block of code repeatedly with a very compact and recognized syntax. Here's the general for. Let's break these down into its three main components. Initialization. This section runs once, right at the beginning of the loop. It is usually used to declare and initialize the loop control variable, such as a count. This sets the starting point of your loop. Condition. This part is a Boolean expression that is evaluated before each iteration of loop. If the condition is true, the loop body executes. If the condition is false, the loop terminates. Important. If the condition is initially false, the loop body never executes. Update. This part runs after each execution of the loop body. It typically modifies the loop variable to eventually meet the exit condition. Usually, this increases the value of I by 1 after each iteration. Without proper updating, the loop may become infinite or never execute as expected. Key points to remember. All three parts: initialization, condition, update are optional, but the semicolons are mandatory. You can place complex expressions in any section, multiple variables, function calls, etc. You can also write an infinite loop. Best practices when using for loop. Limit variable scope. Declare your loop counter inside the loop when possible to keep it local. If the loop counter is declared inside the for header, its scope is limited to that specific loop, and you can reuse the same name in the another loop. Don't forget to exit condition. Missing or incorrect conditions can lead to infinite loops. Always update the counter properly. Forgetting I++ or the proper update may result in a loop that never ends. Different form of the loop: counting up, counting down, loop with complex update logic using multiple variables, and infinite loop using for. This pattern is especially common in embedded systems where the program needs to keep running continuously. Explanation of nested for loops in C. In C programming, a nested for loop means placing one for loop inside another. This structure is very useful when we need to repeat a set of operations in a two-dimensional or multi-level way. As you can see, the code block for the other loop body comes immediately after the other four statements. Optionally, you can include some statements before the inner for loop. Then comes the inner for loop along with its own code block. Finishes, After the inner loop finishes, any additional instructions that needs to run can be placed after it. Using functions inside a for loop in C. In C, you can call functions in any part of the for loop. Initialization, condition, update, and the loop body. This adds a lot of flexibility but also requires caution to maintain readability and efficiency. Calling a function in the initialization section. You can initialize a variable using a function. Note that the function init value is called once before the loop starts. Calling a function in the condition section. Function can be used to determine whether the loop should continue. Here, should continue is evaluated before each iteration. Be careful if the function has side effects, for example, changing variables I/O, it may behave unexpectedly. Calling a function in the update section. You can update variables using function calls. The function next value returns the next value for it. Calling a function in the loop body. Most common use. This is the most typical case. Here, the function print status runs on each iteration. Best practices when using function in a for loop. Keep the for statement clear and readable. Avoid putting too many complex expressions or function call in the header. Ensure function calls do not have unintended side effects, especially in the condition or update section. If the function is computationally expensive, consider catching the result before the loop. In this exercise, we are going to create and display a 10 by 10 multiplication table right in the console. Let's launch Eclipse IDE. In one of our previous lessons, we created a project for learning the switch case statement. We are going to reuse that same project for this tutorial. Just clear the main function and we'll write our new code there. This code will also be available on GitHub and you can find the link in the description section. Step 1. Creating the header row. We begin with a simple for loop using a counter named I. This loop runs from 0 to 10 in each iteration. It prints the value of I using printf, and we reserve 4 spaces for each number to keep everything properly aligned. It's best practice to define the counter variable directly inside the for loop. That way, it stays local and can be reused elsewhere if needed. Step 2, adding a separator line. Now we copy the loop and paste it right below. But this time, instead of numbers, we print the dash character repeatedly to form a horizontal divider. Since each number in the header row takes up to 4 spaces, we repeat the dash character around 40 times. We use %t in printf since dash is character. Step 3, moving to a new line, and the end of each for loop we add printf /n to move the cursor to the next line. This ensures our output remains clean and readable. Step 4, building the multiplication table. Now it's time to create a nested for loop. In the outer loop, we use I to represent the current row number. In the outer loop, we use the I to represent the current row number. In inner loop, we use J to calculate the print the product I by J again with 4 spaces reserved for alignment. At the beginning of each row, we print the value of I followed by a vertical bar using printf. If you are new to printf, check out our earlier videos where we explain it in detail. The playlist link is available at the top of the screen and at the end of this video. Step 5, debugging the program. Next, we debug the program using F6 on the keyboard to step through it line by line and observe the output. Make sure your loop condition is correct. For the inner loop, make sure your loop condition is correct. It's important. For inner loop, j should be less and equal 10. We'll also set breakpoint. We also set breakpoint on line 27 and 33 for the debugger pauses at those points. Step 6, viewing the result once the program runs. Once the program runs, you'll see a complete multiplication table printed in the console, neat and aligned. Step 7, enhancing the visual output. To make the output even cleaner, let's apply a few refinements. In the 27th row and in the first column, we, al- we allocated we allocate just 2 spaces for printing the value of I instead of 1, since it goes up to 10. We shift the separator line 4 spaces to the right by printing 4 blank spaces before the dash loop. Similarly, we shift the top row of numbers 4 spaces to the right using another printf. Now you have a fully function and nearly formatted multiplication table printed to the console. This exercise was a great way to practice for loops in C. What's next? In the next video, we will dive into the while and do while loops. If you are aiming to become a professional embedded systems programmer, learning C is your essential first step. This series is designed to help you master C programming, with focus on real-world applications in embedded systems. Thank you for watching and see you in the next lesson.